In today's lesson, we are going to learn forms of complex numbers. Forms of complex numbers. There are three forms of complex numbers. Cartesian, polar, and exponential. Cartesian form are also known as rectangular form. We have studied z is equal to x plus iy. This was Cartesian form of complex number. We also learned how to calculate modulus and arguments. In our first lesson, there is a connection between modulus argument form or polar form. Our polar form is also known as modulus argument form. Let's check this diagram. Real axis, imaginary axis. This is O. If I mark a point named P, coordinates x comma y, and I also name it Z, a complex number. So this is my right triangle, this is my x values on the real axis, and this is my y values on the imaginary axis. So this is my angle theta, and r is my modulus, or the length of the complex number z. So as we know, r is a modulus, so write z modulus equal, how to find z modulus? We square x, add y, square of y, and whole square root. This is a way to find out the modulus of this. You can also write r equals z modulus. Okay, now from here, if I calculate cos of theta, so I would write adjacent over hypotenuse, which is x over r. From here you can make x the subject, so it becomes x equals r cos theta. And if you calculate sine theta, you have to write opposite over hypotenuse, which is y over r. And from here you can make y the subject, it becomes y equals r sine theta. So now from this we can write z is our complex number. Z is identical to x plus iy, and this is equal to r cos theta plus I r sine theta. Take r as common and you are going to write cos theta plus I sine theta. So this is our modulus dash argument or polar form. Our third form is exponential form. And it is written as or e power I theta. So let's check an example. Suppose if we are told to find the modulus and argument of z equals 2 plus 2 root 3 I. Always first make the diagram so that you should know in which quadrant this complex number lies. This is real axis and this is imaginary. So 0, 1, 2 and a little before 3 would be 2 root 3. Say here 2 root 3. This is our z and 2 unit and 2 root 3 here. This is our angle theta. Now we have to calculate their r, which is modulus, and we write z modulus like this. So square of x means square of 2, square of y means 2 root 3 square, and whole under root. This is the way we find out the modulus, and this gives us 4 plus 2 times 2 is 4, 4 times 3 is 12 square root and 16 square root, which is 4. This is our modulus, and our argument theta which we write like ARG. Argument theta would be opposite over adjacent, means 2 root 3 over 2, and this is tan inverse. Opposite over adjacent is always tan, so write tan inverse of this, cancel 2 and you are left with tan inverse of root 3. Okay, I have told you in our first lesson, I hope, if I am not wrong, make a right triangle. This is 30 degree, this is 60 degree, this is 2 unit, 1 unit, and using the Pythagoras theorem you get root 3 here. So if you write sine 60, this is opposite over hypotenuse root 3 over 2, and cos 60 adjacent over hypotenuse, which is 1 over 2, tan 60 opposite over adjacent, which is root 3, and 60 degree, if I convert it into radians, I have to multiply this with the fraction pi by 180. So I will get pi by 3. So I can write 60 degree equals pi by 3 radians. Now come back to the question. Our argument is tan inverse of root 3, which is pi by 3 radians. Actually tan inverse of root 3 is 60 degrees. So 60 degree is pi by 3 radians. Now z equals 2 plus 2 root 3i in Cartesian form. This is in Cartesian form. In polar form, how we will write this? Our polar form says r times cos theta plus I sin theta. So r is over 4 and cos theta is over pi by 3 plus I sin pi by 3, and this is how you write in polar form. If you need to write the same complex number in exponential form, which is r e power I theta. So you just write r, which is 4, and theta is your pi by 3, so you write I pi by 3 or pi by 3I. Before we proceed and learn backward conversion, let me tell you some important facts with example. And those are to find the product of two complex numbers multiply their moduli and add their arguments. For example, if I am given a complex number z equals 1 plus I and w equals minus 1 plus root 3I, find modulus and argument of ZW. Always first make the diagram. So let's make its diagram first. Real axis, imaginary axis, and this is 0, 1 plus I. This is your I means on the imaginary axis, and you write 1 there. So you get mark. This is your Z. This is your angle theta of Z. Now, negative 1 plus root 3. So a little below 2 would be root 3. So this is your theta of W. And your principal angle would come here. You can name it alpha, and that alpha can be found out by writing tan inverse of, this is root 3 and this is 1 unit means -1, but we know that we are going to write 1 here, so opposite over adjacent means √3/1. Pi/3. So now you find theta of w, which is your argument, from pi. Pi means 180. From this 180, if you subtract alpha, so you will get the theta of w. So pi minus pi/3 will give you this, which is 2pi/3. And your theta argument of z is tan inverse of 1/1, which is actually 1. So this gives you tan inverse of 1 is 45 degree, and in radian it is called pi/4 radians. Now to find the modulus of z, as we are told that multiply their moduli and add their arguments. So let me write here modulus of zw would be z modulus multiplied by w modulus, which is √2 times 2. Okay, let me find out modulus of z. That is x square plus y square, means 1 square plus 1 square whole under root. This is √2. And modulus of w is square of -1 plus square of √3 whole under root. And this gives us 2. So modulus of zw would be 2√2. Now to find argument of zw, we have to add their arguments. And we already found out their arguments. Argument of z plus argument of w. Argument of z was pi/4, and argument of w was 2pi/3, which gives us 11pi/12. Second point, and important, was to find the quotient of two complex numbers divide their moduli and subtract their arguments. So find the modulus and argument. Let me write it for you. Find the modulus and argument of W over Z. For modulus, we will use 2 over root 2. Modulus of W was 2. I'm using the same previous examples results. And modulus of Z was root 2. Okay, because we have surd in the denominator, so we have to rationalize it. So multiply by root 2 and divide by root 2. So we get 2 root 2 over 2. Finally, root 2 will be our answer. This is the modulus of W over Z. For argument, we have to subtract their arguments. So we can write ARG of W minus ARG of Z. So argument of W we found out 2 pi by 3 minus, and argument of Z was pi by 4, and this gives us the result 5 pi by 12. Okay, now come to the point how to switch between forms of complex numbers. Example, convert to Cartesian or rectangular form. So I'm given 4 bracket cos of pi by 3 plus I sin pi by 3. This is my polar form. Now as I know that pi by 3 equals 60 degree, and cos 60 is 1 by 2 and sin 60 is root 3 by 2. So I can write 4 1 by 2 plus I, in place of sin pi by 3 I can write root 3 by 2. Now multiply 4 by 1 by 2 as well as this second term, so I get 2 plus 2 root 3. I. So this is my Cartesian form or rectangular form.